Okay, let's keep the things recorded. Okay. And now, guys, before I start, I hope that you got, I should say, uh, the, the announcement yesterday that when I do the recording of, I should say, the lectures, the Schoology website has a limit, I should say, to the uploading. Then I just upload them on the YouTube. And yesterday night, I just linked a post for you. I post a link for you. Then you can click on it to watch the videos every day if you need to review the materials. Huh?
Mm-hmm.
You got the announcement yesterday?
Yes.
Awesome, awesome. And now let me put back my laptop there upside down to start the day. Okay, these are the notes from my previous class. Let me take them out. And interestingly, there are lots of overlap between your course now with the advanced function class, which I have from 9 to 11. Okay. Okay, guys, let's start the session today. I'm missing some points. Guys, any question about the contents that we covered yesterday?
No.
Any questions?
No.
Nothing?
No.
You are totally fine?
Yes.
Okay, let me get my stuff and also your lecture notes from yesterday. Guys, especially these are the notes which we had from yesterday, especially if I want to make emphasis, put that emphasis on the materials which we learned yesterday. Please remember that working with the logarithmic properties, the things that we worked yesterday, is very crucial, and we are going to have it maybe a lot for your quizzes and for your tests. Then please take care of that stuff and remember to practice a lot. I'm going to post some homeworks for you for today and make sure that you work with them a lot. But before we continue, I'm going to give 2 examples. Let me show you this stuff. Guys, before I just move on, I just want to highlight something with you, for you that we covered yesterday. Yesterday, we said that when you just work with log functions, essentially, the first thing which we take care of it first is that to work with property number 6 and number 5. For example, in one of the examples which we had yesterday, when we look at these functions, we first of all look from the grand scale to see that if we can just use property number 5 or 6 first to decompose that into the sum or the linear sum of the log functions. You remember it from yesterday, huh? Yes, everyone?
Yes.
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 And essentially, I said that you start from looking at number 5 or 6. And in all the examples that we covered yesterday, if you remember, the thing was that we just start from the left to right. For example, we have a product of 2 functions, then we decompose them into the sum of 2 functions, of the log of 2 functions. Or we just started from the ratio of the log of the ratio of a function, we decompose them into the log of the difference of those 2 functions. Essentially, we just walked from left to right. Today, we are going to do 3 examples that we take the reverse direction. We have the functions decomposed into the sum or differences, and now we just want to see what is a compact form. Because look at that. In these 2 properties which we had yesterday, if you start from the left to right, we call that you are decomposing the functions. You had 1 function, 1 term on the left, you have 2 terms on the right. It means that you decomposed it. You had 1, now you have 2 functions. Make sense, guys?
Yes.
Yes, everyone? And now the thing which you want to do right now is that we all want to do something exactly the reverse. We are going to have, for example, two functions of the logs. We are going to have one function then. We have the decomposition. We want to make it look compact, smaller. Huh? That's the plan for today. Everyone is good?
Yes.
Yes, it's good.
And let's see, what do I mean? Let's do some examples and see what do I mean by that. Okay, for example, look at this. I'm going to start with a function. I say that I'm going to work with the, let's say, for example, the log. Everyone can see that? The log of 56. The base is going to be 2 minus the log of 7. The base is going to be 2 minus the log of 5. The base is going to be 2. Okay, I'm just going to work with this one. Guys, when you look at these terms, the thing which you see all is that you have 3 terms. Term 1, term 2, term 3. And all of these functions, what kind of functions they are? They are logarithmic functions. Huh? Now I have a very long expression. I have 3 terms now. I have 1, 2, 3. The question is that, and you will see that, guys, a lot when you just go to university, you just go in any most majors, like you go to engineering, you go to the science degree, you go to the economics or math program, you will see similar things like that, that you are bombarded with lots of terms which they are logarithmic functions. Okay. And the question is that when you are there, the question is that, can I combine these all 3 terms to make it one log functions? Instead of having one function, I make it into the one. I'm going to solve one for you as an example. Then we have a lot to practice and you can just do some example on your own. The first thing which I see is that I take a look. You have many options to do. I take a look at these 2 functions. You see that, guys? Log 7 and log 5 with the base 2. Correct?
Yes.
When I look at this one, this is my preference, which I do. You can do the other way which you want. You can say, okay, okay, I just look at these 2 expressions. I look at these 2 expressions and I just, factor minus from them. What do I mean? You can write it like that. You say, I can just put the minus sign there. And I say, okay, it turns out to be what? Like the log 7 base 2 plus log 5 base 2. Correct? That's what I did. By looking at these 2 terms, I factor minus and I just write them in like that. When I look at this, guys, I see that now I have 2 logs which they are summed together. What property it reminds you that you used yesterday in order to expand the bigger function? Which number was that? Look at property number 5. Look at the right side. Don't look at the left side. Look at this side. I have a log of f of x base b, log of g of x base b. You see that? I have 2 logs, they are summed. Yes? Then what happened to the right side? I noticed that I can just merge them together, multiply them together. Remember it?
Yes.
Yes? I'm going to do the same thing now then. I say, okay, if that's going to be that case, I am going to make it simpler. I say, then the log of 7 base 2 plus log of 5 base 2 becomes what? Log of? I know the base has to be 2 because we do not change the base. But how about this one? I'm adding these two, but they have two different, I should say, terms. This one is 7, this one is 5. It means that if there are some, I multiply them together based on property number 5, becomes how much? 7 times 5 becomes?
35.
35, correct? And I put 35 there. Then I saw that if I work with these two functions first, I can factor minus from them. Then I use property number 5 to make them look smaller, look more compact. The base remains the same, but the arguments are multiplied. At the same time, guys, do not forget this minus sign before. Huh? I have one minus before, correct? Everyone's doing good so far?
Yes.
Everyone says yes if you are so far good.
Yes.
Yes.
Great. How about
Yeah.
you, Gloria?
Yes.
Great. And now, I have one more term left. Which one was that? I had the first term here, which I kept it aside. I said that initially I had the log of 560 with the base 2. Huh? Now, instead of writing these two terms, guys, I have this term, correct? Which it means that it becomes, let me use the green color, minus log of 35 with the base 2, correct? That's essentially the same thing, huh? I was able, by doing the first step, instead of having 3 terms, I have 2 terms. You see that? Okay, and now I look at these two logs. I check 2 things, guys. Please listen very carefully. I check 2 things. The first thing is that for these 2 functions, I have the same base. You see, both of them are 2, correct? And also, after you see I have 2 base, I see that they have been subtracted. You see the minus sign there. It reminds me readily of property number 6, which we covered yesterday. Look at the right side. I have 2 log function, log f of x with the same base b, and the log of g of x with the same base b. The bases are the same, and they have been subtracted. And I see the left side, essentially it becomes to log of one function, which I took f and g, I divide them both together, and I kept the same base b. Right? That's what I did yesterday. It's the last property which we discovered, property number 6. Then, if that's going to be correct, I'm going to extend it to this. I see I have the same scenario. I have 2 log functions. They share the same base, and they have been subtracted. Then I can write it like that. Then I say it becomes equal to the log of. I keep the same base. Property number 6, it tells you you keep the same base. The base doesn't change at all. We keep the same base 2. And now I have 560 and 35. What do I have to do with them?
Divided.
Divide them. By division, you mean I'd say 560 divided by 35. Correct? So far, so good? Okay, but the problem is that, what's the problem? 560 divided by 35, I want to get rid of this ratio. It's very easy. I have a calculator. I can put the calculator 560 divided by 35. Guys, how much do you get?
16.
How much?
16.
16. Rose says that it becomes 16 as a main driver of the log function, and I have the same base 2. Correct? And now, let's see if I can still simplify that further. I have now log 16 with the base, which is 2, equals to. Guys, how much is that going to be? I put the square. I put the question mark inside. And I do not know how much is that. But I have a clue for it. You remembered yesterday, we said that in order to find the answer, we just go from the passenger seat, which is what? 2. We move on to the back seat, which is this question mark. Do you see this color, guys? Do you see this color when I write this?
Yes.
Then from the passenger seat, I jump to the back seat, which is the question mark. I ended up to the main driver's seat, which is equals to 16. That's the method which I use if I do not know the output of a log function. Then, guys, this one here, question mark, how much is that going to be? That 2 to that power becomes 16.
4.
4 means 2 times 2 times 2 times 2 becomes 4, 8, 16. Correct? Right? Then as a result, the main question which we started with, oh my God, sorry about the noise outside. This is fire trucks. Can you hear it at home? It's crazy out there. And now look at this one. I had 3 terms. I ended up with what? Log 16 with 2, which is what? Which is 4. You see how beautiful is that? You start with 3 terms, which they are nasty looking, and they seem so hard to deal with. But I use property number 5 and property number 6 to simplify that to the log of 16 with respect to the base 2. And I learned that the log of 16 with base 2 should be equal to 4 because of this rule. And this one is going to be 4. And it's done. Guys, any questions?
No.
Oh,
No.
No? Faris,
Yes.
does it make sense to you?
No.
No. Which part is that you have some problem with?
Mm, the
Which part?
no, I don't have it.
You don't have,
Yeah, I understand what are you saying. I understand it.
Oh, you got it, huh?
Yes, I got it.
Awesome. And also, Ferris, in case if you need some review again on the properties that we had yesterday, I sent the notice to, I should say, to the main Schoology website yesterday night, and there is a link on YouTube.
Oh,
If you click, that's right, a link.
we have class yesterday night,
That's right.
but
Tuesdays we
I
have 6
think
to 8.
you told us it's Wednesday night. I think Wednesday night and Friday night, 2 night, we have makeup class. I
No, it
think.
was Tuesday night and Friday night.
Oh,
Yeah, again, we had it last week. I reminded you that it's always Tuesday.
okay, it's Tuesday. Right now,
That's
I
right. Not
remember it.
anymore, because from next week we'll have the regular sessions.
Okay,
Yeah.
so every week, Tuesday and Friday, we have makeup.
That's right. Not anymore, because from
Okay.
next week it's going to be back to normal. But in case if you have some problems with these properties, please check the link which is on YouTube now. I have sent a notice to everyone. If you click on the link, you see all the sessions from yesterday. Okay.
Okay.
Awesome. Thanks. And Gloria, Rose, and Philip, any questions?
No.
No.
No? Okay. And now, I'm going to give you now, if you have no questions, I'm going to give you 2 exercises. Okay. Let me write the exercises for you. I'm going to give you 2 exercises. You spend a couple of minutes on it. We have 2 log x minus 1 over 2 log y plus 3 log z. This one. And also, I think this one is good. Start with this. Spend a couple of minutes. You see you have 3 terms. Try to make it as compact as you can into 1 term only. Maybe just I give you 2 minutes to just wrestle with that. Then I just get back to you. I solve it with you. You help me. I write it on the piece of paper then. Okay, guys, are you done? Who's done? Hello? Anybody there? Knock, knock.
No.
Oh, nobody's there?
Yes.
Ah,
Yes.
I suddenly nobody's there.
Yes, I mean nobody's there.
I said knock, knock. Nobody's there. You said no. Okay, guys, let's work it through together. You can follow me, you help me, you jump in. Let me see what can I do. Okay, let's start. Okay, how can I start first? What should I do first? Hello? Somebody's talking? Let me help you. Guys, look at this. The one that we talked about. We said that the log of A with base B, if it has a hat N, when you drive that Lamborghini, it falls off behind the car. Or you can look at the right. You see that when the hat is behind the car, you can bring it back to the function itself, then it gets to the right side, the left side. You see that? It was property number 3. Now look at this. I have these ones. I have 2. I have 1 over 2. And I have 3. They are like the hats behind the car, correct? Then I can take every one of those hats into the head of the main driver, which essentially means what? Essentially means that you can write these expressions like this. You can write this expression like, you say that it becomes the log. You have your x. Get what? Power 2. Minus, you have the log, you have the y, it gets what power? 1 over 2. You have plus, you have the log, you have the z. What power does it get?
3.
3. Correct? And now, what's going to happen now? I start from left. I see 2 log function, which they are subtracted from each other. What property does it remind me of?
Property 6.
Property 6. That's so true. By just looking at these 2 terms, I can write them as what? As the log of, I know that I have to do what? I have to do, right, x squared divided by what? Y to the power 1, 2. Correct? Because that's which property? Property number 6. Two log functions subtracted, they turn out to be one log function, but I divide them, f of x and g of x, right? Then so far, I see that this expression, it turns out only to 1. Then it becomes what? Becomes, then I have log of x squared y over with powered 1, 2, plus the third term. What is my third term? Plus log of z to the power what? 3. Correct, guys? So far, so good.
Yes.
Say yes if everything is
Yes.
fine.
Yes.
Only 1 person, 2 persons is yes?
Yes.
Yes.
Awesome.
Yes.
Great. I feel the energy now. So far, then I have from 3 terms, I ended up with 2 terms. 2 log functions, they have the same base. What is the base there? I haven't written the base. It means it is what?
10.
10. That's right. Guys, when you do not write the base, it is assumed that the base is going to be 10. That's a convention. Then I see these 2 logs are summed. What property does it remind me of? Huh? Two logs are summed. Isn't that property number 5? Two logs are summed, the same base, then I multiply them in 1 log, correct? I do the same thing. I write the log. Yes? You see that, everyone?
Yes.
And simply what do? I multiply this term into the other term. What do I get at the numerator? X squared times what? Z to the power 3 and y 1 over 2. Does it make sense, guys?
Yes.
Or if you can want to continue that further, it's an optional step. You can write it as the log of x squared z to the power 3 square root of y. Because y to the power 1 over 2 can be written as the square root of the y. Is there anything in this whole process that it makes you confused and you need some explanation? Hello? Everyone? You see, I
Yes.
started from a term which is 3 logs. I use property number 2. Then I use property number 6. Then from the result, I use property number 5 to reach to only 1 term. You see, 3 terms on top is equivalent to only 1 term. You see how beautiful is that?
Mhm.
Yes.
Yes? Guys, do you have any questions?
No.
No? Who said no?
Me.
Philip, huh?
Mhm.
Yeah, how about you, Ferris? Ferris?
There's $1.
Huh? Hello? Maybe he's went to the washroom. How about you, Gloria?
No.
You're okay?
Yes.
How about you, Rose?
Yeah, I'm good.
Awesome. Then if everyone is good, we move on with one last example. I'm going to give you this function. I'm going to give you the log of x squared minus y squared minus the log of x plus y, and everything is multiplied to 1 over 2. Correct? Now you please, guys, use those properties which you have learned to see that if you can compact them into only one logarithm function. Okay? I'm here. If you have any questions, please ask me. Are you done? Hello?
Not yet.
Okay. Is it good 2 more minutes?
Yes.
Great. You guys, who's done now? Okay, let's do that together. Huh?
Sure.
Help me. You help me. Are you done, Philip?
No.
No. Rose, are you done?
Almost.
Almost. How about you, Gloria?
Not yet.
Not yet. How about you, Ferris? 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 Okay, maybe he just stepped aside for a minute, but that minute is getting too long. Okay, guys, let's work it together and let's see what can we just get from this. Okay, first of all, guys, imagine that this 1/2, it doesn't exist. Or you have two options. You can multiply 1/2 to both sides, or you can keep 1/2 outside, then it starts from whatever is left inside. Both way is possible. A slighter, simpler way is that to keep 1/2 outside, starts working with the thing which is inside. Then look at the 1/2, when all the terms are simplified. Huh? We can do both methods, but this one, we are going to do that way. Well, what was that? No, it was a piece of banana. Okay, you see that if I take only look at these two terms, if I take a look at these two terms only, what do I get? Oh, my coffee got cold. Ah, taste that. Look at this. What does it remind me, guys? I have two log functions which both share the same base. What is the base there?
10.
10. And they have been subtracted from each other, correct? And now, two log functions, I see they are subtracted and they share the same base. It takes me right over to which property, guys?
6.
Property number 6, right? Which it means that I can take these two functions in front of one log function and divide them and keep the same base, correct? Then, if that's gonna be the case, I'm gonna write it that way. I'm gonna write it like, let's say, take these two log functions and write it as one log, correct? One log. What is f of x? What is g of x? X squared minus y squared and x plus y, correct? What am I gonna do? I'm gonna simply divide them to find the ratio of it. It's x squared minus y squared. The numerator is always the function which comes first. The denominator is the function who comes last. Make sense? Guys, please answer, say yes, if it makes sense.
Yes.
Makes sense, guys?
Yes.
Great.
Yes.
How about Ferris and Gloria?
Yes.
Ferris? Okay. And now I have this one. What is missing there, guys? From coming here to there, what is missing? I forgot to add something. This is this coefficient 1/2, huh? I put 1/2 before this, and it turns out to be this one, correct? So far, so good.
Yes.
Then I say, okay, let's simplify the things a little. I say it equals to, I'm going to write it down, log of oh, my battery is gonna die. Hopefully not soon. Before we go to the break, then I charge my laptop. Can I write x squared minus y squared as x minus y times x plus y divided by x plus y? Can I write it like that? X squared minus y squared, it's written as x minus y times x plus y. Is it correct?
Yes.
Yes, everyone?
Yes.
Yes, Philip?
Yes.
Yes,
Yes.
Gloria? Yes. And I still have 1 y over 2 there. Guys, what's happening there? I have x plus 1 denominator, x plus 1 numerator. Can I remove them? Can I factor them out?
Yes.
Can I kick them out?
Yes.
Yes? Then if you say that's correct, I'm gonna factor x plus 1 from there. So far, so good. Then what I'm left with? I'm left with the log of, what is left?
X minus y.
That's right. I'm only left with x minus y because I kicked x plus y out. Because there was 1 here, 1 there, I kicked them out. I know that I still have 1 over 2 there, correct?
Yes.
I'm almost done, but I can do something. I say, oh my God, I see what? I see a hat before a car. I say, okay, let's take it inside. Then I write log of x minus y to the power of what? You see that, guys, if I write there?
Yeah.
To the power of 1 over 2. So far, so good.
Yes.
Yes.
And the power of 1 over 2 is what? Is the square root, correct? X minus y. And I'm done. Because I know that the power of 1 over 2, as you remember, it becomes the square root of that expression. You remember that, huh?
Yes.
Yes, Gloria?
Yes.
Yes, Philip?
Yes.
Yes, Rose?
Yes.
Then you see that from these two expressions of the log complicated functions, I only get to this function, log of this expression, log of the square root of x minus y. Does it make sense to all?
Yes.
Yes.
Do you have any questions?
No.
No? Are you sure, Philip, Rose, Gloria?
Yes.
Yes.
No questions?
No.
Then please enjoy your break for 15 minutes. In the meantime, I recharge my laptop. I see you back, guys, by 12:16. Good?
Yes.
Fantastic. See you guys in 15 minutes then. Let me put my battery on before it dies. Okay. And now let's put this. I see you guys in 15 minutes. Hello, guys. Are you back?
Yes.
Oh, great.
Yes.
Awesome. Let me see. Okay, I think I should have still enough battery. Let me put the things back there. Okay. Now, no questions, guys, so far. Everyone is doing great.
Yes.
Yes.
Okay, fantastic, fantastic. Okay, let's move on. And with the new topic today, okay. Now, guys, today we are going to talk about something which essentially this one is also a shared topic with the advanced function class. And that's essentially, that's what we call that the change of the base. And from this one, we just move on to talk about the natural logarithms, which is all over the place in science, engineering, and whatever. Then we start from this. Okay, this is gonna be the topic. Oh, these ones are dying. I forgot to just put the tab on yesterday night, and the marker is dying. Guys, before, if you remember, we said that when we talk about the log function, we said that the log function of something as we call that x, we always looked at the base as b as always being a constant. When we were working with our identities, we were taking care first that the base should be equal. And if the bases were equal, we were using those properties, 1 to 6, correct? Then that's what we talked about that I should say so far. But there are so many instances that the base itself becomes more important than the main driver of the function. Essentially, I mean that, for example, if you are driving the Lamborghini, sometimes the passenger becomes more important than the driver itself. Then as a result, we're looking for a way in order to manipulate the base of a function. Huh? Make sense, guys, so far? You know what are we going to do? What I'm going to do is that in order to change the base, I'm going to define a ratio. And in that ratio, I'm going to write two log function. One log on the top, one log on the bottom. So far, so good. But I need to, if I have two Lamborghinis, I have to find for each one driver and one passenger, correct? And now I come to think myself, I say, okay, I'm going to do this whole process because, give me 1 second, guys, I should be back in a second. I said to myself, okay, the whole purpose of doing this, why am I doing this? I'm doing this in order to change the base, to manipulate the base, which originally it was B. Now, I want to change it to A. For example, if the base was 5, I want to change the base to 2. Huh? That's the plan. Always remember, that's the big plan we want to do. We want to change the base from B to A. For example, from 5 to 3. Then if it's going to be the plan, I'm going to write here A. Because that's the base which I'm looking for. That's my favorite base right now. Okay. Then I'm done with the passengers of these two Lamborghini. I need two drivers now. What is going to be my first driver on the top? I take the X, which is on the top. I take it all the way, sit it there. X is going to sit there. And the old base from the old function comes all the way to sit as a driver of the new function. You see what happens? Hello?
Yes.
Are you sleeping, guys, back there? Who's sleepy now?
No.
Philip, are you sleepy?
No, no, no.
Rose, are you sleepy?
No.
Gloria, are you sleepy?
No.
Faris, are you sleepy? If no one is sleepy, guys, everyone says yes.
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 Philip?
Yes.
Awesome. Guys, that's the plan then. Does it make sense to everyone, huh? This is, we just call that the base, change of the base. Okay. I'm going to show that to you why it is this, why we can change the base by doing this procedure, huh? That the plan is that I'm going to prove this to you, huh? Then please also you learn how to prove it because it may comes into your exam, huh? We prove it, we do one example, then we just move on to the natural logarithms function, okay? The thing is that in order to prove this, you learned it so far that any logarithmic function, I'm starting from the left. In order to improve this equation, guys, the whole plan is this. I say, okay, I'm going to prove it. I start from the left, which is log x of b, then manipulate the left side, and I find myself suddenly on the right side, and I say, ah, there, this is proved. That's the plan. In order to prove this, I always, as you know, I use the twin brother of the log functions. What is the twin brother of the log functions? Hello? The twin brother is an exponential function, huh? I say that, imagine that the log of x with the base b, which I have on the left, imagine that equals to something. It equals to, let's say, I call that it equals to m, for example, huh? Yes, guys?
Yes.
What I'm going to do is that I take, if that's going to be the case, the thing which I have done always so far, I have learned it, that I can write it as an exponential format. What is the exponential format of this function? I say that I go to the passenger seat, which is B, correct? Then I move to the back seat of the Lamborghini, which is M. Then I end up to what? To the main drive, which is X. These are two are equivalent forms. These two functions are like twin brothers. You cannot say the difference. Correct? Is it correct, guys?
Yes.
If that's going to be the correct, then I know that if there is an equality like that, I can take the log from both sides. I can take the log from both sides, and still I have the equality, correct? And we have done that at the beginning of the sessions a couple of days ago when we try to get from these functions to the log functions. We say that, okay, we take the log from both sides. Essentially, I mean that if the main function was this, which was b to the power m equals to x, I say I take the log from both sides. I push the log. I give every side one Lamborghini. Correct? But guys, right now I give them both sides the log, but I haven't specified the base. And that's the critical point now. We can define the base at this stage. You say that I give the log to both of the equality which I had, but I'm going to choose the base to be this. Okay? Then what type of base I can choose? Can I choose base A as an option? Yes?
Yes.
And now, when I'm there, I see, I can say, what kind of property, guys, you see here? Of those 6 properties.
Probably.
Huh? I can't hear you.
Property.
Which one? 2, you see that the Lamborghini car, which the driver is driving and he's wearing a hat. There have been blows off his hat behind the car, right? Then as a result, what do I get? I get the m, the log of b with the base a equals to what? The log to the right side, which is x with the same base as a. Correct? Is it correct, guys?
Yes.
Now, guys, look at this one. Compare this result to the one which we have up there. How do they look similar? Can I make this one to look like that? Philip?
Yes.
Can I make this equation to look like the one up there?
Yes.
How? Rose? What do you think?
I have no idea.
Guys, look at that. If I divide both sides by the log of b over a, what happens? From the left side, what do I get? I get n. The log of b over a vanishes. You can kick them out, correct? And you end up with what? From the right side, you have your log of x with the base a. And at the denominator, you have what? You have the log of what? B with respect to a. Correct? Is it correct, guys?
Yes.
You know what happened?
Yes.
What happened there?
The move the
I simply divided both sides of this equation over log b over a. And now, guys, compare this result with this result up there. Aren't they the same on the right side? Log xa, log xa, log ba, log ba. You see? You see? You see that they are the same?
yes.
Then
Yes.
as a result, if the both sides are the same, it means that the left side is the same and you have proved it. Then it means that if I replace m, what was m initially? M was log xb, huh? Look at here. If I replace m with log x with the b equals to what? The same side, which is the log of x with the base a with the log b with the same base a. You see that? Everyone see that? And essentially
Yes.
that's how we proved this change of base identity. And I'm going to call this one property number what? We have covered 6. I'm going to call this property number 7. Any questions, guys?
No.
Who said no?
Gloria.
Thank you, Gloria. How about you, Rose?
No.
Thank you, Rose. How about you, Philip?
No.
Are you sure?
Yes.
Now, when I give an example, then when we do the example, you are understanding what happened there. What did we do? Look at this. I'm going to write this one. I'm going to say that I'm going to write the log of a function. I'm going to write the log of 100, okay, to the base what? To the base, let me choose that. 5, for example. Okay. I'm going to ask you, please change the base to the log with the base of 10. Essentially, I'm going to change the base from 5 to 10. Please spend 30 seconds on it, then I do that for you then. Change the base to the log of 10. Are you done?
No.
Let me do this one for you, then I give you one example to do it later. Look at this one. I'm going to change to the base 10. It means that if I want to change the base based on the formula which I have, which is, I'm calling it property number 7, I'm going to do what? I'm going to have then 2 logarithm with the desired base. It means that then I write it like that. I say it's going to be the log 1 on top. Everyone sees that, what I'm writing? And log on the bottom. So far, so good. The second step, the first step was that, oh my God, I was collapsing my laptop. Then the first step which I did in order to change the base, because I want to change the base to 10. The first step is that to write 2 logarithm function, to have 2 Lamborghini car. The second step is that to give the base which I'm looking for to each one of those Lamborghinis. What is the base which I'm looking for? Is it 10? I put 10. And what is the second step? Look at this formula. We said that when we give the desired function, we take the main argument as a main driver of the top and the base of the old function to the driver of the bottom function. Huh? What I'm going to do right now is this. Then I'm just going to say, I'm going to take 100 to take it here, and I'm going to take 5, take it here. You see that? Is it okay so far? Yes, guys?
Yes.
Yes? Okay. I'm at this stage. Any questions? Philip, Gloria?
No.
Everyone is fine?
Yes.
And now, what's going to happen now? I say, Philip, how about you? Are you okay?
Yes.
Faris, are you okay? Okay. What's going to happen now, guys? I do suspect that this one going to get even easier. Why? Because I can write it like that. Instead of writing log of 100, I can write the log of 100 over base 10. I can, for 100, I can write what? 10 multiplied to 10. Is it correct?
Yes.
Because 100
Yeah.
is 10 by 10. And whatever I have at the denominator, I think I can also change that one too. Instead of 5, I write what? 10 divided by 2. Correct? With the same base 10. My plan was that when I change the base, try to have the main drivers a multiple of the main function. Guys, what the numerator just reminds you of? 10, the log of 10 by 10. Does it remind you of the property number 5, that you had a log and two things were multiplied in front of the log? Then you said that I can decompose them into one log. Log 1, log 2. You remind you of that? If that's true, then can I write it like this? I say it becomes equal to log. Everyone see what I'm writing?
Yes.
Then I say it becomes log 10, the base 10, plus the log, again 10, with the base 10. Is it nice? Does it make sense, guys? It is this one. Log 10 by 10 becomes log 10 plus log 10. Because this is multiplied, I know that I can decompose that in two logs with the plus sign. Any questions on that, guys?
No.
Philip?
No.
Rose?
No.
Faris? And now look at the one at the denominator. We have log 10 over 2 by 10. Which property is relating to that? Is it like property number 6? That two things are divided, which I decompose them on two logs with the minus sign. It looks like that, huh? Property number 6. Then it means that I can write this one as a log of 10. The base is going to be still 10, huh? But with the minus sign of log, which is going to be what log? What the number is going to be?
2.
2 with the base 10. Correct? Any questions so far?
No.
Philip?
No.
Gloria?
No.
Great. Guys, I look back again at these functions. It reminds me of property number 2, that we said that the log of b with b equals to 1, and we proved that also. It means that if the main driver and the passengers are going to be the same, the whole log is replaced with 1. You remember it? I have lots of these cases here. Log 10 with base 10. How much is that going to be?
1.
1. Again, log 10 by 10. I'm going to write it here. Log 10 with the base 10 becomes 1. Again, plus log 10 with the base 10 plus another 1, correct? Add the denominator, guys. I have log 10 again by the base 10. It's going to be another 1 plus, oh, sorry, not plus. My mistake. It has to be minus. Log 2 with base 10. I think I cannot do anything further with it. I can leave it where it is. That's right. I write minus log 2 base 10. Then as a result, if you simplify that further, you will see that you get to this one. You get 2 plus 1 minus log of 2 with base 10. You see what happened? Guys, are you okay?
Yes.
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 Any questions?
No.
No.
Then
No.
you see that when you work with the different bases, with the different logarithms, how it's if you change the base, and the purpose was that whenever you change the base, you can how you manipulate the function. Sometimes it makes it easier, huh? That's right.
Yes.
Correct. Guys, the thing which I'm gonna ask you to okay, no, I think that's fine. I'm just going to give you one more example. You do that yourself. In terms of the changing the base, what time is it? It's 5:44. Let me give you this one. Guys, please change the base of the function, which I'm just going to introduce to you. The log of. Let's put it as the log of, let's say the log of what possibly I can choose. The log of 35 with the base 10. I'm going to ask you to change the log, to change the base from 10, go to the base, which is going to be 7. Okay. Does it make sense? Everyone sees that?
Yes.
In
Yes.
the meantime, you do that, I recharge my laptop. Again, I'm afraid that it just may die. And when this is a charge a little, then we go back to do some more stuff. And please ask any questions if you have while you do that. Okay, are you done?
No.
And in the meantime, let me just take the attendance. Ferris, are you still there? No? Okay, let's go for the attendance. Guys, who is Jing Lee? Not in the
Jing-
class, huh?
Who?
Jing Lee.
I think the principal teacher.
Ah, okay. I have Rose absent. No, I'm kidding. Rose is there. I have Philip absent, which I mean present. Ferris, are you
No,
there?
I'm present.
I know, I'm
here,
kidding.
don't worry.
I'm kidding. And Gloria is absent today.
For sure.
No, Gloria is there. I'm kidding. But there is Ferris, guys. Ferris. 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 Nothing? Okay. Guys, are you done now or? Okay. I think I should have enough battery now. It's good to go back. Guys, are you done? Everyone?
Not yet.
Not yet. Who said not yet?
In rows.
Rows. How about Philip and Gloria?
No.
Not yet.
But I'm sure Ferris is done. Ferris? Are you done? Okay, guys. Let's do that together. Then you follow me to see if we needed to do more stuff. Guys, I want to change the base. What's the first thing which I do? I draw a line. Huh? That's the first thing, because I need to put two Lamborghini car. One on the top, one on the left. The first thing, draw a line. The second thing, put two Lamborghini up and down. What is the third step, guys? Can you guess? I choose the base, which I prefer. I'm gonna change the base to 7, huh? Then I choose the base 7, I put it there on the base of these two Lamborghini car. Correct? Then what is left? I have these two things, the old parts from the old car, because you are changing your old Lamborghini to two new. You are taking some spare parts from the old Lamborghini. The 35 is going to come here, and the 10 is going to come here. Correct? So far, so good.
Yes.
And now, essentially, that's done. You change your base. You are done now. You change your base. Any question?
No.
No.
Rose?
No.
But you may feel some curious. You say, what can I do with this log 37 over 7? Because I know that 37 is 7 times 5. Huh? Because 35 is 7 times 5. I say, maybe I can do something. Let's see if it ends somewhere. Now we are done. We do not need to do anything, but because we are curious, we go to the next step. We say, let's explore some stuff. I have the log. My base for sure is going to be 7. I know 35 is how much? 7 times 5. And I have my log of 10 with the base 7. Correct?
Yes.
And when I see that, I say, look at that. Then I just decompose 35 into 7 times 5. What do I get? I get something very similar to the property number 5 that we discussed about. That we have a log and there are two things multiplied in front of the log. The multiplication, it means that they are fighting. They have two swords. They just want to fight. Then what do? I give each one a Lamborghini. It means that this one can be written as the log of 7 base 7, remember, plus the log of what?
5.
That's right, base 7. Is it correct, guys?
Yes.
Yes. I can't do anything with my denominator. I keep it whatever it is. 10 with the base 7. Okay. What's going to happen now? What is spectacular there? What catches your eye? Look at this one. I have log 7 over 7. Property number 2. that if the driver and the passengers are the same, we replace them with number 1. Yes?
Yes.
It means that then it becomes what? Becomes 1 plus log of 5 over 7 over the log of 10 divided by 7. And that we are done. We stop it from here. Any questions?
No.
No? Okay. Now, then we have no questions. Then I should say I need 2 minutes to wrap up with the other things we had to cover it for today. Then we should be done for today. Are you tired, guys?
Yes.
Oh, me too. How about you, Roseanne? Gloria?
I'm
Yes.
fine.
Philip and me are tired. The boys are tired. The girls are okay. Oh, that's... Philip, what's happening there with us?
We
boys-
just
Uh-huh.
you're tired.
That's right. I think the boys, we got tired. The girls are not. Okay. Let's do something in 2 minutes. Then we should be done. Guys, when we talked about the big change of the base, we're going to talk about that more for tomorrow. But remember that when we talk about the change of the base, essentially we come to discuss of something. And that thing is going to be this. Then we say that if I have a logarithm function, we define a number, which that number is this. We said that if I write an expression, I don't want you to learn this because that's for demonstration. We said that 1 plus 1 over x, the power x, when we say that the x goes to infinity, becomes too large, then the result is going to be a number 2.71, for example. Okay, 2.71. We call the whole expression that demonstrates with E. You see E? Like Edward? But when we say E, we are talking about a number which is predefined, 2.71. Correct? In the past, for example, we saw this number, pi. How much was pi?
3.14.
That's right. We had 3.14. Now we have something different. Now we learned also one more constant in the math, which we call that E, natural number or Neper number. We call that E is always fixed to 2.7 as P, which is always fixed to 3.1. Huh? Then whenever you see in math E, you can think of number 2.7. Okay. As when you see pi, you think of 3.14. Whenever you see E, you think of 2.71. Huh? Then, everyone is okay so far?
Mm-hmm.
In the concepts of the logarithm function, then if I say, for example, the log of any number, I call that x, and I call the base 2.71. It makes sense, huh? Because the base is positive. The base is not 0 and it's not 1. Then I'm allowed to get the base like that, huh? Then whenever you see that, which is essentially is like this, you say that the log of x, instead of 2.71, what can I write instead? E, huh? Because I learned E is going to be this. Based on the convention which we're going to follow from tomorrow, this logarithm, I call that instead ln of x. You see that? This is essentially that's what we are going to work on that tomorrow. We say that whenever we have a logarithm function, that the base of that function is a natural number, which is 2.71. Instead of writing log with the base e, I write ln. ln means the logarithm with the base e. Does it make sense, guys? Yeah? Just remember this one today for tomorrow. Oh, by the way, tomorrow is Thursday, huh?
Yes.
Tomorrow, guys, is going to be the very last day that we have no class on the morning. We catch up on Friday from 6 to 8. From next week, everything should be fine, back to normal. Huh? Then when we will be back on Friday morning, I'm going to work with the natural logarithms, which is going to be the ln function. ln means the logarithm with the base e. Any questions?
No.
No?
No.
And if you have no questions, I'm going to post some homeworks for you guys that you work it and you submit it by Friday morning. Okay?
Okay.
Yes? Then if you have no questions, I hope that, by the way, you can find the video lectures recorded on YouTube. I'm going to send you the link today before the end of the day. Sure?
Sure.
Yes.
Awesome. No questions, guys? Then
No.
please stay tuned for my homework and also the video lectures, which is on the YouTube. If you have no questions, have a nice day, guys. See you on Friday.
Bye.
Bye-bye.
Bye.
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 Bye-bye. See you guys later.